All right, Algebra 2, Lecture 2.3 and 2.4. For essay 2816, the student will use the properties of logarithms to expand logarithmic expressions. And we'll talk about what that means post haste. Here we go. One thing we have to think about, note, if we don't see the base of a given logarithmic expression, then the base is an implied 10. For example, e.g., log 100 equals 2 is how we read that. What it means is log base 10 of 100 is equal to 2. Is what it means. 10 to the second power is equal to 100. So if you don't see the base, it's an implied base 10. All right? Otherwise, if you see, the base will be whatever you see. If you don't see the base, it's an implied 10. And you read it, log 100 equals 2. Properties of logarithms, we're going to be talking about 3 of them today. The product property says that if you have the log of a property, of a product, that's two things that are multiplied together, you can rewrite that logarithm in what we call expanded form. Just take the log of the first one, write a plus sign, and then take the log of the second one. This expression is equal in value to this expression. That's called expanding a logarithm. Okay? There's the quotient property. If you take the log of a quotient, that's equal to the log of the numerator minus the log of the denominator. Okay? So we've taken this log base b of m over n, and we've written it as, we've expanded it into the difference of the log of the top minus the log of the bottom. We'll be doing that today, and the power property says if you take log base b of something that's raised to some power, we can move whatever this exponent is, just think of it as moving it to a position of a coefficient. We moved it from here to here. And it gets physically larger when you do that. If it's an exponent, it'll be small. It'll be a small case. It'll be like a superscript, smaller. And when you move it to a position of a coefficient, it will be physically larger. It will look bigger. Okay, so those are the three properties of logarithms we're going to use, and we're going to rewrite exponential expressions, expanding them. That means we're going to go from here to here. It makes it take up more room physically. It's expanding. Okay, so here we go. Use the properties of logarithms to expand the following logarithmic expressions. I'll look at this, and all I see is that log base 10, log, you can't see the base, log x to the 6th. The only way I can expand this is to use my quotient. My power property. If I raise the logarithm of something is raised to some power, the thing we're taking the log of, we can move that power to a position of a coefficient. So that's what I'm going to do, and I'll be finished. I'm going to move this to here, and it's going to get bigger because it's now a coefficient instead of an exponent. And we're finished. Pretty easy to expand that one. If you see log again, here we have base 10, so you don't see it, so it's base 10. Log xy or log x times y, they both mean exactly the same thing. We're going to use the product property. The product property says if you have the log of a product, take the log of the first one plus the log of the second one. The base remains constant. So I'm looking at that situation. We'll say the log of the first one, base 10. So log x plus the log of the second one. That's all there is to it. It's called expanding logarithmic expressions using the properties of logarithms. Okay? Let's take a look at another one. Now here's one we got to think about a little bit. We did rewriting rational exponents, rewriting them as radicals, and vice versa, rewriting radicals as rational exponents. So I'm going to think of this as x to the 1/3. Okay, so this is the log of x to the 1/3. There's an implied 1 there. The 1 slides up, the 3 slides under, and the radical symbol disappears. Okay? And now I'm going to employ the power property and move this exponent to a position of a coefficient, and it's going to get physically larger. 1/3 log x. Now on today's worksheet, they're going to think of this as 1/3 times log x over 1, and they're going to write it like this. 1 times log x is log x. 3 times 1 is 3. So they'll move it to a position of a coefficient, and then they'll multiply this by 1/3. So they're thinking 1/3 times log x over 1. 1 times log x is log x. 3 times 1 is 3. And this is how you're going to see the result written. Usually, you'll see it written like this. But on today's worksheet, for whatever reason, the authors of the worksheet wrote their answers in this form, okay? So let's take a look at this one. Again, here we have a radical. I want to rewrite it as a rational exponent. Got to remember, if I can't see the index, it's an implied 2, and that's an implied 1. So this is actually thinking of it as log x to the 1/2 power. And now I'm going to move that exponent to a position of a coefficient using the power property. I made that exponent awfully big, that coefficient rather. There we go. I just moved this to here and made it physically larger. And as I said in this problem, they're going to think of this as 1/2 times log x over 1. That's how they're thinking of it. And then 1 times log x is log x. 2 times 1 is 2. In most cases, you're going to see it written like this. But on today's worksheet, they're going to write it like this. Hopefully you can see that these two expressions are equal in value. All right, let's take a look at another one. Here it looks like we're taking a log of a quotient. The base is 10. We can't see it. So we're going to use or employ the quotient property that just says if you have a log of a quotient, a fraction, a rational expression, however you want to say it, you take the log of the top one minus the log of the bottom one, the log of the numerator minus the log of the denominator. And that's called expanding the logarithmic expression. So that's what we were asked to do, so that's what we're going to do. This will be just log A minus log B. And we're done. We took the log of the numerator minus the log of the denominator, and we've expanded it. These two expressions have the exact same value for any real numbers, A or B, A and B. Right. So here we go. Any real numbers where that's defined. I'm looking at another situation here where I've got a radical. So I'm going to think of it as a rational exponent. This time it's base 5, look at that. All the rest of them were base 10. Doesn't matter, we're just going to think of this as a to the 1/3 power. Remember, the 1 slides up and the index slides under it. Now I'm going to employ the power property and move this to a position of a coefficient, 1/3 log base 5 of A. And then I'm going to remember that our worksheet today is going to rewrite this using this train of thought. Think of it as log base 5 of A over 1 times 1/3. And then multiply the top. 1 times log base 5 of A is log base 5 of A. And 3 times 1 is 3. So they'll rewrite this the way it's usually represented. They'll rewrite it like this. Why they do that, we may never know, but they're doing it. So I just wanted to clue you in. And here's the last two we're going to mess with. Yep, that's it. We want to rewrite this as log base 10. Scooch this up a little bit. Using the quotient property, so I'm going to take the log of the top minus the log of the bottom, the log of the numerator minus the log of the denominator. The base remains the same. And we've rewritten it. And so among my choices, I would look for this one. And here we have another power property. I'm just going to move this exponent from a position of an exponent to a position of a coefficient. It gets physically larger when I do that. And I'm done. Okay. And those are the properties we're employing. you can do this.